The Soviet Union built a 640-ton aircraft that could carry entire locomotives, a tank with 5 turrets requiring 12 crew members, and a missile-launching boat that flew just above water at 340 miles per hour. While the West focused on practical engineering, Soviet designers created machines so outrageous, they seemed pulled from science fiction. These weren't concept drawings or propaganda fantasies, they were real, operational vehicles that pushed the boundaries of physics and common sense. Welcome to the most insane chapter of military engineering history. The Antonov An-225 Mriya, the Sky Titan. A single aircraft engine failure would ground most planes, but the An-225 Mriya could lose 3 of its 6 engines and still fly safely. This Ukrainian-built monster wasn't just the world's largest aircraft, it was a flying impossibility that redefined what could take to the skies. Stretching 275 feet long with a wingspan wider than a football field, the Mriya weighed 640 tons when fully loaded. Its cargo hold could fit 50 cars or house 4 crew members comfortably in its engineering bay. The aircraft required 32 wheels just to distribute its massive weight on runways, with 20 of those wheels being steerable for ground maneuvering. Originally designed to piggyback the Soviet Buran space shuttle, the Mriya became a commercial cargo hauler after the space program ended. It routinely transported objects once thought impossible to move by air: 130-ton generators, wind turbine blades longer than most aircraft, and even diesel locomotives. The sight of this 6-engine giant attracted crowds wherever it landed, becoming a symbol of Ukrainian engineering pride. The aircraft's unique design featured twin vertical stabilizers and engines mounted above the wings to avoid ground debris when loading oversized cargo. Its maximum altitude of 36,000 feet meant it could fly intercontinental routes while carrying payloads that would require multiple cargo ships to transport by sea. Tragically, the only completed Mriya was destroyed during the 2022 Russian invasion of Ukraine, ending the operational life of aviation's most ambitious achievement. The T-35 heavy tank, the land battleship. Imagine a tank so massive it needed 11 crew members and got lost because its own turrets blocked the driver's vision. The T-35 wasn't just a tank, it was a mobile fortress that embodied Soviet excess in armored warfare. At 45 tons and nearly 32 feet long, the T-35 featured 5 turrets bristling with weapons: one 76mm main gun, 2 45mm cannons, and up to 7 machine guns. This firepower required a crew larger than most aircraft, with gunners, loaders, and commanders spread across separate fighting compartments that couldn't communicate effectively with each other. The tank's design philosophy assumed it would break through enemy lines while creating a sea of fire around itself. In reality, the T-35 proved mechanically unreliable and strategically useless. Its 500 horsepower engine could barely push the massive hull to 19 miles per hour on roads, and cross-country mobility was practically non-existent. Only 61 T-35s were ever built, making them more valuable as parade vehicles than combat weapons. During World War II, most T-35s were lost to mechanical breakdowns rather than enemy action. The few that saw combat were quickly destroyed or abandoned when their complex systems failed under battlefield conditions. The T-35 represented the interwar period's obsession with multi-turreted land battleships, a concept that looked impressive on paper but proved disastrously impractical in real warfare. It remains the only 5-turreted tank ever to reach mass production, a testament to Soviet willingness to build the impossible. The Lune-class Ekranoplan, the flying warship. Soviet engineers created a 240-foot missile-armed vehicle that wasn't quite a plane and wasn't quite a ship. It was something entirely new that skimmed across water at 340 miles per hour while carrying enough firepower to sink an entire naval fleet. The Lune-class Ekranoplan exploited ground effect physics, using the air cushion created between its massive wings and the water surface to achieve lift without actually flying. This allowed the 240-ton vehicle to cruise just 13 feet above the waves, too low for radar detection but too fast for naval defenses. Armed with 6 P-270 Mosquet anti-ship missiles, the Lune could engage targets 75 miles away while remaining virtually invisible to enemy sensors. Its 8 turbojet engines provided enough thrust to accelerate this flying fortress to speeds that would make most naval vessels look stationary. The craft's unique design challenges included saltwater corrosion from constant spray, limited operational conditions requiring calm seas, and the need for specially trained pilots who understood both aviation and maritime operations. The International Maritime Organization classified ekranoplans as ships rather than aircraft, creating regulatory confusion that persists today. Only one Lune-class ekranoplan was completed before the Soviet Union's collapse ended the program. The surviving vehicle now sits as a museum piece on the Caspian seashore, a reminder of Soviet ambitions to revolutionize naval warfare through physics-defying engineering. The Buran Space Shuttle, the Soviet Space Phantom. While NASA's space shuttle required pilots for every mission, the Soviet Buran accomplished something American engineers thought impossible. It flew to orbit and landed completely unmanned, controlled entirely by computers in an era when most people had never seen a personal computer. The Buran program represented the Soviet Union's most expensive space project, involving over 1,000 companies across the country. Unlike the American shuttle, which carried its main engines into orbit, Buran rode atop the massive Energia rocket, making it a true passenger spacecraft rather than a rocket-powered aircraft. On November 15, 1988, Buran completed its only spaceflight, a flawless two-orbit mission lasting 208 minutes. The spacecraft launched automatically, maneuvered in orbit using onboard computers, and executed a perfect runway landing without any human intervention. This automated capability was decades ahead of its time, predating modern autonomous vehicle technology by 30 years. The shuttle's cargo bay could accommodate satellites up to 56 feet long, and its crew cabin was designed for 6 cosmonauts. Additional crew members could ride in the cargo area for specialized missions. The spacecraft's heat shield used different materials than NASA's shuttle, optimized for the harsh conditions of Soviet launch sites. Despite its technological success, Buran never flew again. The Soviet Union's collapse in 1991 ended funding for the program, and the only operational orbiter was destroyed in 2002 when its storage hangar collapsed. The program's cancellation marked the end of Soviet dreams of routine space transportation. The VDNKH robot, the Soviet android dream. In 1959, when most people thought robots existed only in science fiction, Soviet engineers unveiled a 1.8-meter humanoid robot that could execute 18 commands, respond to light and sound, and perform for amazed crowds at Moscow's VDNKH Exhibition Center. The VDNKH robot represented the Soviet Union's early experiment in humanoid robotics, designed to showcase technological superiority during the Cold War. Standing on a specially built stage in front of the electrification pavilion, the robot performed demonstrations every 2 hours, combining engineering achievement with theatrical showmanship. This early android could perform basic human movements, respond to voice commands, and navigate simple obstacles using primitive sensors. While crude by modern standards, the robot's capabilities were revolutionary for the 1950s, predating industrial robotics by decades, and demonstrating Soviet commitment to automation technology. The robot's design philosophy reflected Soviet optimism about human-machine collaboration, envisioning a future where robots would support workers in factories and daily life. Its public demonstrations captured imaginations and inspired a generation of Soviet engineers to pursue robotics research. The VDNKH robot's legacy extends beyond its mechanical capabilities to its cultural impact, representing a time when robotics was emerging as a field full of promise. It embodied the Soviet Union's drive to innovate through technology, blending practical demonstration with symbolic hope for technological progress that would define the space age. The MAZ-7907, the 24-wheeled nuclear nightmare. Soviet engineers built a truck so massive it needed 24 wheels, 2 tank engines, and electric motors at every wheel, just to move a 100-ton nuclear missile across rough terrain. And only 2 of these mechanical monsters were ever completed. The MAZ 7907 stretched 92 feet long and weighed 66 tons empty, designed specifically to transport the RT-23 Molodets intercontinental ballistic missile. This road-mobile nuclear launcher represented the ultimate expression of Cold War mobility, capable of carrying world-ending firepower to any location accessible by road. 2 1,250 horsepower gas turbine engines from T-80 tanks powered electric generators that fed individual motors at each of the 24 wheels. This turbine electric drive system allowed the massive vehicle to navigate rough terrain while maintaining the precision needed for missile deployment. 8 of the 12 axles were steerable, enabling surprisingly tight turns for such a massive vehicle. The truck's articulated frame and independent hydropneumatic suspension for each wheel helped it traverse difficult terrain without losing stability. Despite weighing over 200 tons when loaded, the MAZ 7907 could achieve speeds of 25 miles per hour on roads and maintain mobility across unpaved surfaces that would stop conventional vehicles. The end of the Cold War eliminated the need for road-mobile nuclear missiles, leaving the MAZ 7907 without a mission. One surviving chassis was later used to transport an 88-ton ship 250 kilometers across Belarus, proving the vehicle's incredible load-carrying capability, even in civilian applications. The Caspian Sea Monster, the original Ekranoplan. American spy satellites detected something so bizarre skimming across the Caspian Sea that CIA analysts couldn't determine if it was a plane, a ship, or something entirely new. They simply called it the Caspian Sea Monster, and it became one of the Cold War's most mysterious weapons. The KM, or Korabl Maket, was the world's first operational ground effect vehicle, a 348-foot experimental craft that flew just above the water surface using 8 massive turbojet engines. Weighing over 540 tons, it was simultaneously the heaviest aircraft and fastest ship ever built when it began testing back in 1966. This flying Leviathan exploited ground effect physics to achieve impossible performance, skimming across water at speeds up to 460 miles per hour while remaining invisible to radar. Its massive size, longer than a Boeing 747 with engines producing 127,000 pounds of thrust, made it detectable by satellites but honestly incomprehensible to intelligence analysts. The KM's experimental nature meant constant testing and modification throughout its operational life. Soviet engineers used it to develop techniques for ground effect flight, leading to later military applications like the Lund-class Ekranoplan. Its unique capabilities included the ability to carry massive payloads at aircraft speeds while operating from any large body of water. The monster's career ended in 1980, when pilot error caused it to crash into the Caspian Sea during a test flight. No lives were lost, but the unique vehicle sank and remains on the sea floor, taking with it secrets of Soviet ground effect technology that took decades to fully understand. The Zveno flying aircraft carrier, the aerial mothership. Soviet engineers solved the problem of limited fighter aircraft range by creating something that sounds like science fiction. A massive bomber that carried smaller fighter planes on its wings and released them in mid-air for combat missions. The Zveno project transformed a TB-3 heavy bomber into a flying aircraft carrier, mounting up to 5 smaller aircraft on its wings and fuselage. I-16 fighters would attach to the bomber before takeoff, ride to the target area, then detach for independent combat operations before returning to land at conventional airfields. This aerial mothership concept addressed the fundamental limitation of 1930s fighter aircraft. Their short range made them useless for long-distance missions. By carrying fighters to the battle zone, the Zveno system extended their operational radius by hundreds of miles, effectively creating mobile air bases that could appear anywhere within the bomber's range. The system required extraordinary pilot skill and precise coordination. Fighter pilots had to attach their aircraft to the bomber's wing mounts, ride through potentially turbulent flight conditions, then detach cleanly without colliding with the carrier aircraft or other fighters. The complexity of these operations limited the system's practical applications. Despite successful testing and limited combat use during World War II, the Zveno concept was abandoned as aircraft technology advanced. Longer-range fighters and aerial refueling made the flying aircraft carrier unnecessary, but the project demonstrated Soviet willingness to pursue unconventional solutions to tactical problems. The 1K-17 Shati laser tank, the Soviet death ray. While science fiction promised laser weapons in the distant future, Soviet engineers built a working laser tank in the 1970s that could blind pilots and destroy optical equipment using focused light beams generated by synthetic rubies weighing 66 pounds each. The 1K-17 Shati mounted an array of 13 laser emitters on a tank chassis, each focusing powerful light through synthetically grown rubies to create coherent beams capable of damaging enemy equipment. Unlike modern military lasers designed to burn through targets, the Shati was built to blind and disorient rather than destroy. The system's ruby-based laser technology represented cutting-edge Soviet research into directed energy weapons. Each ruby crystal required precise manufacturing and alignment to focus the laser beams effectively, making the entire system incredibly complex and expensive to maintain. Combat applications included disabling enemy optical systems, blinding pilots during low-level attacks, and potentially damaging sensitive electronic equipment. The laser array could fire in pulses to prevent overheating while maintaining effectiveness against multiple targets. The Shatya never saw combat deployment, remaining an experimental system throughout its development. The complexity of maintaining the laser array, combined with the emergence of more practical anti-aircraft systems, led to the program's cancellation. However, the technology developed for the Shatya influenced later Soviet research into directed energy weapons. The Bartini-Beriev VVA-14, the Soviet Millennium Falcon. 5 years before Star Wars introduced the Millennium Falcon, Soviet designers created an aircraft that looked like it came from a galaxy far, far away. A vertical takeoff amphibious plane designed to hunt American submarines anywhere in the world's oceans. The VVA-14's bizarre elliptical shape served multiple purposes. The entire fuselage acted as a lifting body, while inflatable pontoons allowed water operations and vertical takeoff capability. This unique design enabled the aircraft to operate from land, water, or even rough seas where conventional seaplanes would be destroyed. Designed by Italian engineer Roberto Bartini, working in the Soviet Union, the VVA-14 was intended to counter American Polaris submarine-launched ballistic missiles. The aircraft would patrol vast ocean areas, using its amphibious capabilities to land on water for extended surveillance missions or emergency operations. The prototype's test flights revealed both the promise and problems of its unconventional design. While the lifting body concept worked, the complex systems required for vertical takeoff and amphibious operations proved unreliable. The aircraft's unique appearance and advanced capabilities made it a showcase of Soviet aerospace ambition. Only one prototype was completed before the program ended in the mid-1970s. The VVA-14's influence on science fiction design is unmistakable, and its advanced concepts predated modern vertical takeoff aircraft by decades. The surviving prototype remains a testament to Soviet willingness to pursue revolutionary aircraft designs. These 10 mechanical monsters prove that Soviet engineers never met an impossible idea they wouldn't try to build. From flying tanks to nuclear-powered trucks, they created machines that pushed physics to its limits and common sense beyond recognition. While many failed spectacularly, others achieved the impossible and changed military technology forever. What's your favorite Soviet engineering nightmare? Share your thoughts below. Hit that like button if these crazy machines amazed you, and subscribe to Future Facts for more incredible stories of human ingenuity gone wild. Until next time, keep questioning everything. Right now, a 1970s spacecraft traveling at 38,000 miles per hour through the void between stars has detected something that's rewriting our understanding of the cosmos. Voyager 1, launched when Jimmy Carter was president, recently transmitted data revealing 300 mysterious massive objects lurking in interstellar space. Objects that shouldn't exist according to our current theories. After surviving computer failures, memory corruption, and radiation levels that would kill a human instantly, this car-sized probe continues making discoveries that challenge everything we thought we knew about the universe beyond our solar system. The impossible mission that refused to die. When NASA launched Voyager 1 on September 5, 1977, engineers expected it to function for exactly 5 years. The spacecraft was designed to study Jupiter and Saturn, then quietly drift into the cosmic void as a technological relic. Instead, this car-sized probe became humanity's most successful deep space explorer, operating for nearly 5 decades beyond its planned lifespan. The mission's longevity stems from brilliant engineering and fortunate timing. Voyager 1 exploited a rare planetary alignment that occurs once every 175 years, using gravitational assists from Jupiter and Saturn to accelerate toward the outer solar system. This grand tour trajectory, conceived by mathematician Michael Minovich, transformed what should have been a routine flyby mission into an epic journey to the stars. Today, Voyager 1 operates with computer systems containing just 70 kilobytes of memory, less than a single smartphone photo. Its instruments run on power generated by decaying plutonium, producing less electricity each year as the radioactive fuel ages. Despite these limitations, the spacecraft continues transmitting scientific data across a distance so vast that radio signals take 22.5 hours to reach Earth. The probe's survival represents one of engineering's greatest triumphs, proving that well-designed systems can exceed their creators' wildest expectations when pushed beyond all reasonable limits. Breaking through the solar system's final barrier. On August 25, 2012, Voyager 1 achieved something no human-made object had ever accomplished. It crossed the heliopause and entered interstellar space. This boundary, located 121 astronomical units from the Sun, marks where our star's influence ends and the true void between stars begins. The crossing wasn't a simple transition, but a complex journey through what scientists call the twilight zone. Voyager 1 spent months navigating this region, where solar wind particles clash with the interstellar medium in a cosmic battle that creates unexpected phenomena. The spacecraft detected dramatic increases in galactic cosmic rays, mysterious particles from distant stellar explosions, while simultaneously observing sharp decreases in solar particles. What made this discovery revolutionary was its timing and precision. Scientists had theorized about the heliopause for decades, but Voyager 1 provided the first direct measurements of this cosmic boundary. The probe's instruments revealed that interstellar space contains particle densities 100 times higher than the protected region within our solar system. The heliopause itself proved more complex than predicted. Rather than a sharp boundary, Voyager 1 encountered a thick, dynamic region where magnetic fields twisted and particle densities fluctuated wildly. This discovery forced scientists to completely revise their understanding of how our solar system interacts with the galaxy beyond. The mysterious hum of deep space. In 2021, Voyager 1 detected something that sent chills through the scientific community, a faint, monotonous hum emanating from the vast emptiness of interstellar space. This wasn't random noise, but a persistent vibration from plasma waves in the interstellar medium, revealing that the space between stars isn't truly empty. The discovery came from Voyager 1's plasma wave system, which had been monitoring larger eruptions from the Sun that affect interstellar gas. When these solar outbursts quieted, scientists noticed a background hum that had been masked by the more dramatic events. Cornell University's Stella Koch-Acker, who led the research, described it as very faint and monotone because it is in a narrow frequency bandwidth. This cosmic hum provides unprecedented insights into the structure of interstellar space. Unlike the chaotic environment within our solar system, the interstellar medium maintains a steady, predictable rhythm that Voyager 1 can monitor continuously. The probe essentially acts as a cosmic weather station, reporting conditions in a region no spacecraft had ever explored. The hum's consistency allows scientists to track how interstellar plasma is distributed throughout the galaxy. Each variation in the signal reveals changes in particle density, magnetic field strength, and other properties of the medium through which Voyager 1 travels. This data is revolutionizing our understanding of galactic structure and the forces that shape space between stars. Computer failures and miraculous recoveries. Voyager 1's journey hasn't been without terrifying moments that nearly ended the mission forever. In November 2023, the spacecraft suddenly stopped sending coherent data, instead transmitting meaningless streams of binary code that completely baffled NASA engineers. The problem actually originated in the flight data system, where a corrupted memory chip prevented normal operations. Now, this failure was particularly alarming because it affected the spacecraft's ability to communicate with Earth. While Voyager 1's radio signal remained strong, indicating the antenna was properly aligned, the data it transmitted was just complete gibberish. Engineers faced the nightmare scenario of losing contact with humanity's most distant explorer, just as it was making groundbreaking discoveries in interstellar space. The solution, though, required extraordinary ingenuity. NASA engineers spent months analyzing the corrupted memory, eventually determining that about 3% of the flight data system's memory had been damaged. They developed a workaround that relocated essential code to undamaged memory sections, essentially performing remote surgery on a computer 15 billion miles away. The repair process was agonizingly slow. Each command took 22.5 hours to reach Voyager 1, and responses took another 22.5 hours to return to Earth. The heliopause's shocking behavior. Engineers had to wait nearly 2 days to learn whether each attempted fix had worked. The successful restoration of communications in April 2024 represented one of the most challenging remote repairs in space exploration history. Recent observations from Voyager 1 have revealed that the heliopause, the boundary of our solar system, behaves in ways that really contradict decades of scientific theory. Rather than maintaining a stable position, this cosmic border moves, shifts, and creates irregular angles that leave researchers struggling to explain what they're observing. The heliopause's instability became apparent when comparing data from Voyager 1 and Voyager 2. Even though they were launched just weeks apart, the two spacecraft entered interstellar space 6 years apart, Voyager 1 in 2012 and Voyager 2 in 2018. This timing difference suggests the boundary itself moved significantly during that period. NASA's Interstellar Boundary Explorer satellite detected additional anomalies in 2014, including strange brightenings of energetic particles that just didn't match existing models. These observations suggest the heliopause experiences dramatic fluctuations driven by forces scientists are only beginning to understand. The boundary's complexity extends well beyond simple movement. Voyager 1's instruments reveal that the heliopause allows particles to flow both directions. Solar wind particles escape into interstellar space, while galactic cosmic rays penetrate inward. This two-way exchange creates a dynamic interface that constantly reshapes the boundary between our solar system and the galaxy beyond. These discoveries have profound implications for understanding how stellar systems interact with their galactic environment and how cosmic radiation affects planetary atmospheres throughout the universe. Cosmic rays and the radiation reality. Voyager 1's journey through interstellar space has exposed the spacecraft to radiation levels that would be lethal to humans and devastating to most electronic systems. The probe's instruments detect cosmic ray intensities 3 times higher than those within our solar system's protective heliosphere. These cosmic rays aren't ordinary radiation but high-energy particles accelerated by distant supernovae and other violent cosmic events. They travel at nearly the speed of light and can penetrate solid matter, causing cumulative damage to electronic components over time. Voyager 1's continued operation in this harsh environment demonstrates the remarkable resilience of 1970s engineering. The spacecraft's cosmic ray subsystem has documented how these particles vary as Voyager 1 moves through different regions of interstellar space. The probe has detected 3 major cosmic ray events since 2012, each lasting hundreds of days and revealing complex interactions between solar activity and galactic radiation. These measurements provide crucial data for future interstellar missions. Understanding cosmic ray patterns helps engineers design shielding systems for spacecraft and habitats that might one day venture beyond our solar system. Voyager 1's radiation exposure data serves as a real-world test of how technology performs in the galaxy's most extreme environments. The probe's survival also reveals unexpected properties of interstellar space itself. Certain regions appear to provide natural shielding from cosmic rays, while others concentrate these deadly particles into focused beams that could threaten future explorers. The 300 mysterious objects discovery. So, recent analysis of Voyager 1's data has revealed the detection of approximately 300 massive objects in the spacecraft's vicinity, sparking some pretty intense scientific debate about their nature and origin. These objects, identified through subtle gravitational effects and particle interactions, actually represent one of the most intriguing discoveries in the probe's 47-year journey. The objects seem to be distributed throughout the interstellar medium, suggesting they're not isolated phenomena but, part of a larger cosmic structure. Their masses range from asteroid-sized bodies to objects comparable to small moons, yet they emit no detectable light or radio signals. This invisibility makes them incredibly difficult to study using traditional astronomical methods. Scientists have proposed several explanations for these mysterious objects. They could be dark matter clumps, primordial black holes, or previously unknown types of interstellar debris. Another possibility is that they represent a new class of cosmic object that forms in the unique conditions of interstellar space. The discovery really challenges our understanding of what exists in the supposed emptiness between stars. If these objects are common throughout the galaxy, they could represent a significant fraction of the universe's missing mass. Their gravitational effects might influence star formation, galactic structure, and the evolution of planetary systems. Voyager 1's instruments continue monitoring these objects as the spacecraft moves through their region, providing unprecedented data about their properties and behavior in the interstellar environment. Technology surviving the impossible. Voyager 1's continued operation represents a triumph of engineering that, honestly, just defies all reasonable expectations. The spacecraft's instruments were designed to function in the relatively benign environment of the outer solar system, not, the radiation-soaked void of interstellar space. Yet they continue operating at temperatures that would freeze most modern electronics solid. The probe's power system, which is based on radioisotope thermoelectric generators, produces less electricity each year as its plutonium fuel decays. NASA engineers have been forced to shut down non-essential systems one by one, prioritizing the most scientifically valuable instruments. Heaters that once kept components warm have been turned off, yet the instruments continue functioning despite experiencing temperatures hundreds of degrees below freezing. This survival really stems from the robust design philosophy of 1970s aerospace engineering. Components were built with massive safety margins and redundant systems that, honestly, modern cost-cutting measures often eliminate. The spacecraft's analog systems prove more resilient to radiation damage than the digital electronics that dominate contemporary spacecraft. NASA's ability to maintain Voyager 1 across such vast distances showcases the evolution of deep space communication. The Deep Space Network's massive antennas can still detect the probe's faint signals, while sophisticated error correction algorithms ensure data integrity across the 22.5-hour communication delay. The mission's longevity provides invaluable lessons for designing future interstellar probes that must operate independently for decades or even centuries while traveling to nearby star systems. The heliosphere's protective shield. Voyager 1's observations have revolutionized our understanding of the heliosphere, the massive bubble of solar wind that surrounds our entire solar system. This protective shield, stretching 11 billion miles from the Sun, acts as cosmic armor that deflects most galactic radiation from reaching Earth and other planets. The heliosphere's structure proves far more complex than scientists initially believed. Rather than a simple spherical bubble, Voyager 1's data reveals a dynamic, ever-changing boundary that responds to solar activity, galactic magnetic fields, and the solar system's motion through space. The Sun's 450,000-mile-per-hour journey around the galaxy creates a bow shock where the heliosphere plows through the interstellar medium. This cosmic shield's importance really cannot be overstated. Without the heliosphere's protection, Earth would be bombarded by lethal cosmic radiation that could strip away our atmosphere and sterilize the planet's surface. The shield's effectiveness varies with solar activity. During solar maximum, increased solar wind strengthens the barrier, while solar minimum periods allow more galactic radiation to penetrate. Voyager 1's measurements show that the heliosphere's shape changes constantly as it encounters different regions of interstellar space. Dense molecular clouds can compress the boundary, while sparse regions allow it to expand. These variations affect the radiation environment throughout the solar system, potentially influencing climate patterns and biological evolution on Earth. Understanding the heliosphere's behavior helps scientists predict how our solar system will fare as it moves through different galactic environments over millions of years. Legacy of the Ultimate Explorer. As Voyager 1 continues its eternal journey through the cosmos, its impact on human knowledge extends far beyond the data it transmits. The mission has fundamentally changed our perspective on our place in the universe, revealing both the vastness of space and the remarkable resilience of human ingenuity. The spacecraft carries the famous Golden Record, a collection of sounds, images, and messages from Earth intended for any extraterrestrial intelligence that might encounter it. While the chances of alien discovery remain infinitesimally small, the record represents humanity's first attempt at interstellar communication and, really, our hope for cosmic recognition. Voyager 1's discoveries have inspired numerous follow-up missions. The Galileo and Juno missions to Jupiter, the Cassini mission to Saturn, and planned missions to Uranus and Neptune all trace their origins to Voyager's initial reconnaissance. The probe's identification of potentially habitable moons like Europa and Enceladus has redirected the search for extraterrestrial life toward these icy worlds. The mission's longevity demonstrates that well-designed systems can operate far beyond their intended lifespans when supported by dedicated teams of engineers and scientists. NASA expects Voyager 1 to continue transmitting data until at least 2025, with some instruments potentially operating until 2030. Even after its instruments fall silent, Voyager 1 will continue traveling through the galaxy for millions of years, carrying its golden record as a testament to human curiosity and our desire to explore the unknown. The probe represents humanity's first step toward becoming a truly interstellar species. Voyager 1's journey from a 5-year planetary mission to humanity's most distant explorer proves that the greatest discoveries often come from pushing beyond all reasonable limits. This remarkable spacecraft has revealed the true nature of interstellar space, detected mysterious objects in the cosmic void, and demonstrated that human ingenuity can overcome seemingly impossible challenges. As Voyager 1 continues its eternal voyage through the stars, it carries with it our hopes, dreams, and unquenchable curiosity about the universe. What other secrets await discovery in the depths of space? Share your thoughts below, hit that like button, and subscribe to Future Facts for more incredible space exploration stories. Until next time, keep looking up. Deep within the moon's core, something unexpected is happening that has renowned physicist Michio Kaku issuing urgent warnings to the scientific community. Recent seismic signals detected by advanced monitoring systems suggest our celestial neighbor isn't the geologically dead world we once believed. These mysterious tremors from the lunar interior could reshape our understanding of planetary evolution and potentially impact future Artemis missions. As humanity prepares to return to the moon, these discoveries reveal that our closest cosmic companion still harbors secrets that could change everything we thought we knew about lunar geology. The moon's hidden geological life. What if everything we thought we knew about the moon being a dead, inactive rock was completely wrong? For decades, scientists have described the moon as essentially geologically inactive, slowly cooling as it orbits Earth. This view portrayed our celestial neighbor as a silent, frozen world in the final stages of solidification with nothing interesting happening beneath its surface. Recent discoveries are shattering this long-held assumption. Advanced seismic monitoring has detected unexpected signals emanating from deep within the moon's core, suggesting ongoing geological processes that challenge our fundamental understanding of lunar evolution. These aren't minor tremors but significant seismic events that indicate the moon's interior remains far more dynamic than previously imagined. The implications extend beyond mere scientific curiosity. As NASA's Artemis program prepares to establish permanent human presence on the lunar surface, understanding the moon's internal activity becomes crucial for mission safety and success. These seismic signals could indicate areas of instability that might affect future lunar bases, mining operations, and long-term human habitation plans. Michio Kaku has been particularly vocal about these findings, emphasizing that what we're witnessing could represent the final chapters of the moon's geological story, a rare cosmic window that humanity is fortunate to observe and study before it disappears forever. Michio Kaku's scientific warning. Renowned theoretical physicist Michio Kaku has emerged as one of the most prominent voices, warning about the significance of recent lunar seismic discoveries. During his recent lectures and public appearances, Kaku has emphasized that these signals from the moon's core represent far more than routine geological activity. They could indicate fundamental changes occurring within our celestial neighbor. Kaku's concerns stem from the timing and nature of these seismic events. The moon's core, which scientists believed was in its final stages of cooling and solidification, appears to be undergoing unexpected changes that could have long-term implications for the Earth-Moon system. These aren't gradual, predictable processes, but sudden, measurable events that suggest something significant is happening deep within the lunar interior. The physicist has stressed that humanity exists in a unique cosmic moment. We're witnessing the moon's geological death throes, processes that operate on timescales we can barely comprehend. In another billion years, the moon's core may freeze completely solid, making current observations irreplaceable scientific data about planetary evolution. Kaku's warnings extend beyond academic interest to practical concerns about future lunar exploration. Understanding the moon's internal dynamics becomes crucial as humans prepare to return to the lunar surface and establish permanent settlements. The seismic activity could affect everything from habitat placement to resource extraction operations. NASA's advanced seismic detection systems. NASA's cutting-edge seismic monitoring technology has revolutionized our ability to detect and analyze lunar geological activity. The agency's latest instruments represent a quantum leap beyond the Apollo-era seismometers that first detected moonquakes in the 1970s, offering unprecedented sensitivity and precision in monitoring the moon's internal processes. The Farside Seismic Suite, scheduled for deployment around 2026, will be the first seismometer placed on the moon's far side. This positioning is crucial because it allows scientists to triangulate seismic events with much greater accuracy than ever before. The instruments are approximately 30 times more sensitive than their Apollo predecessors, capable of detecting even the faintest tremors from deep within the lunar interior. Additionally, the Lunar Environment Monitoring Station near the South Pole will provide continuous seismic monitoring for extended periods, unlike the limited-duration Apollo missions. This long-term observation capability is essential for capturing rare events and establishing patterns in the moon's internal behavior that might otherwise go unnoticed. These advanced systems might finally confirm whether the moon experiences slow quakes tied to core readjustment, similar to Earth's slow earthquakes that take days to subtly shift stress. Such phenomena could explain the mysterious seismic pulses that have drawn scientific attention and concern from researchers like Michio Kaku. The moon's internal structure revealed. So, modern analysis has revealed that the moon's internal structure is actually far more complex than we previously understood. The lunar core resembles Earth's in miniature, featuring a solid inner core that's surrounded by a fluid outer core, but with some unique characteristics that make it especially interesting to planetary scientists. The moon's inner core, for instance, has a radius of about 240 kilometers, and is primarily composed of iron, surrounded by a partially molten outer core that extends to about 350 to 360 kilometers. This structure generated a significant magnetic field billions of years ago, much like Earth's current magnetic field, providing evidence of ancient geological activity that has since diminished, but hasn't entirely ceased. What makes recent discoveries particularly fascinating is that the core didn't just switch off after cooling. Instead, it appears to be experiencing these final phases of activity that modern instruments can now detect. The entire moon is actually shrinking slightly in volume as it continues to cool, causing its brittle crust to wrinkle and form ridges or scarps. Some of these surface features are remarkably young in geological terms, like as recent as 200 million years old, indicating that cooling and contraction processes are still happening today. The ongoing seismic activity confirms that the moon is still adjusting to these internal changes, making it a dynamic rather than a static celestial body. Artificial intelligence uncovers hidden lunar secrets. One of the most remarkable aspects of recent lunar discoveries, honestly, involves artificial intelligence analysis of decades-old Apollo seismic data. Scientists have been feeding Apollo-era seismic recordings into modern machine learning algorithms, and the results are just revolutionizing our understanding of lunar geology. These precious recordings from Apollo seismometers have been sitting in archives for over 50 years, but they're now revealing secrets that were hiding in plain sight all along. When Apollo astronauts first deployed seismometers on the lunar surface, computers were room-sized and had less processing power than today's smartphones. The analysis techniques available in the 1970s were, well, primitive compared to what we have now. Modern AI can detect patterns and anomalies that were simply impossible to identify with 1970s technology. These sophisticated machine learning systems can distinguish between genuine lunar activity and instrument artifacts with, honestly, unprecedented precision. Patterns that human analysts dismissed or never even noticed are now being flagged as significant geological events. NASA scientists describe this process as revolutionary, comparing it to having a conversation with someone for 50 years and suddenly realizing you've been missing half of what they've been saying. The AI analysis has identified thousands of previously unrecognized seismic events, suggesting that the moon's interior is far more active than anyone realized. The Earth-Moon gravitational dance. The relationship between Earth and Moon is, in fact, a gravitational partnership that has shaped life on our planet in some pretty profound ways. The Moon acts as a gravitational anchor, preventing Earth from wobbling chaotically on its axis, and maintaining the climate stability that allowed complex life to evolve and thrive. Michio Kaku often emphasizes that Earth is unusually stable for a planet its size. Most planets would wobble chaotically, but the Moon holds Earth steady, sort of like training wheels on a bicycle. This stability has enabled the slow, steady development of ecosystems and eventually human civilization. Earth's tilt of 23.5 degrees, which is responsible for our seasons, would change unpredictably without the Moon's stabilizing presence. The Moon's gravitational influence goes beyond just creating ocean tides. It also creates these slight bulges in Earth's crust. This tidal flexing generates heat through friction, contributing to our planet's internal warmth and geological activity. It's kind of like Earth receiving a constant, gentle massage from the Moon's gravity, helping maintain its dynamic interior. Any changes in the Moon's core structure could, in theory, subtly influence this delicate relationship over geological timescales. The seismic signals that concern scientists like Kaku might indicate mass redistribution within the Moon that could eventually affect Earth's climate cycles, though, such changes would happen over thousands of years, rather than within human lifetimes. Risks to future lunar missions. As humanity prepares to return to the Moon through NASA's Artemis program, understanding lunar seismic activity becomes a critical safety concern, rather than merely scientific curiosity. The recent seismic signals detected from the Moon's core raise important questions about the stability of potential landing sites and the safety of future lunar habitats. NASA's analyses have identified thousands of young tectonic ridges on the lunar surface, some potentially still active today. These ridges indicate areas where the Moon's crust is under stress, creating potential hazards for future missions. Unlike Earth, the Moon's crust lacks water circulation to heal cracks naturally, meaning that once fractured, the brittle lunar surface remains vulnerable to further instability. Future Artemis missions or private mining operations might inadvertently drill into areas near fault lines without fully understanding the consequences. The lunar regolith, the layer of loose, fragmented material covering the Moon's surface, sits atop a complex network of faults and stress zones. Mining operations that disturb this delicate balance could potentially trigger moonquakes or surface collapses. The stakes are particularly high because lunar bases will be completely dependent on their structural integrity. On Earth, earthquake-damaged buildings can be evacuated while repairs are made. On the Moon, a habitat breach could be catastrophic, exposing astronauts to the vacuum of space with little warning or escape options. The Moon as a planetary laboratory. While we often think of the Moon simply as Earth's companion, astronomers and planetary scientists view it as a perfect laboratory for understanding the evolution of countless worlds throughout the galaxy. The Moon represents an intermediate step in planetary development, larger than asteroids but smaller than Earth-like planets, providing crucial insights into how different-sized worlds evolve. Watching the Moon transition from a molten core to a solid one offers glimpses into how exoplanets evolve, whether they can maintain protective magnetic fields, and their potential for supporting life. One of the most critical factors for habitability is a planet's magnetic field, which shields its surface from harmful cosmic radiation. These fields are generated by molten, electrically conductive cores. The Moon once possessed such a protective field, but as its core cooled, that protection faded. By studying the Moon's seismic signals and understanding exactly how its core is solidifying, scientists can develop models predicting how long smaller rocky exoplanets might maintain their protective magnetic shields. This knowledge proves vital for identifying potentially habitable worlds among the thousands of exoplanets discovered by space telescopes. The unexpected seismic pulses from the Moon's core provide new data points for these models, helping scientists understand planetary evolution across the universe. Advanced monitoring technology. NASA's next-generation lunar seismic monitoring systems represent unprecedented technological advancement in our ability to study the Moon's internal processes. These instruments far surpass the capabilities of Apollo-era equipment, offering sensitivity levels that can detect even the most subtle geological events. The Farside Seismic Suite will mark the first time humans have placed seismometers on the hemisphere of the Moon that never faces Earth. This positioning allows scientists to triangulate seismic event sources with much greater precision than previously possible. The instruments are 30 times more sensitive than Apollo equipment, capable of detecting faint tremors from deep within the lunar interior. The Lunar Environment Monitoring Station will establish long-duration seismic monitoring near the South Pole, where Artemis missions plan to build permanent human presence. Unlike Apollo instruments that operated for limited periods, this system will continuously monitor lunar seismic activity for months or years, essential for capturing rare events and establishing long-term patterns. These advanced systems might finally confirm whether the moon experiences slow quakes tied to core readjustment, similar to Earth's slow earthquakes that gradually release energy over extended periods. Such phenomena could explain the mysterious seismic pulses that have captured scientific attention and prompted warnings from researchers like Michio Kaku about the moon's changing internal dynamics. Advanced monitoring technology. Michio Kaku often highlights that humanity exists in a rare cosmic window, a fleeting moment in astronomical time when we can witness and study the moon's internal dynamics before they cease forever. In another billion years, the moon's core may freeze completely solid, making current observations irreplaceable scientific data about planetary death. This perspective transforms lunar exploration from mere curiosity to urgent scientific priority. We're not just studying a neighboring world. We're capturing data during a unique period that will never repeat itself. The moon provides a live demonstration of how small planetary bodies evolve and eventually become geologically inactive. The seismic signals detected from the moon's core might represent one of the final chapters in a 4.5 billion year story. As the lunar interior continues cooling, these tremors will become increasingly rare until they stop completely. Once the core solidifies entirely, the moon will truly become the dead world scientists incorrectly assumed it already was. Scientists often discuss the importance of being in the right place at the right time. In astronomical terms, humanity exists in an incredibly narrow window. After the moon has cooled enough for us to study its interior, but before it freezes completely and goes silent forever. This unique moment gives us opportunities not just to understand our nearest celestial neighbor, but to develop models applicable to countless worlds throughout the galaxy. The lessons learned from the moon's core could help identify potentially habitable exoplanets and understand how geological evolution affects their ability to support life. The mysterious seismic signals from the moon's core represent far more than geological curiosity. They're windows into planetary evolution happening in real time. Michio Kaku's warnings remind us that we're witnessing the final chapters of the moon's geological story, a rare cosmic opportunity that won't last forever. As humanity prepares to return to the lunar surface, understanding these internal dynamics becomes crucial for mission safety and scientific advancement. The moon continues teaching us about planetary evolution, magnetic field generation, and the delicate relationships that make life possible throughout the universe.